Okay, so on to the slightly more advanced electrolysis concepts. Going back to what we had talked about previously, you guys already know that an electrolytic cell is a cell in which you get a non-spontaneous redox reaction that requires a chemical current to occur. And we already know that we are essentially creating chemical energy, creating chemical reactions from that current. So that's the main thing to understand. Sorry, that's of course my puppy Danger, freaking out for some reason or another. Okay. Um, so the main kind of new piece of information that I want you guys to absorb today is that a guy by the name of Faraday came up with a really interesting observation a while back. What he found is that whenever we do electrolysis, for every mole of electrons that we liberate, we get essentially 1 Faraday, guess the name of the guy who discovered this, of electrical charge. And this goes in both directions. Essentially what he's saying, what Faraday kind of discovered or observed, right, is that the amount of electrical current that you use is proportional to the number of electrons that you liberate. Pretty cool, huh? So really, really basic concept, but very important as well. So again, if you put in 1 Faraday of electrical charge, you're going to liberate 1 mole of electrons. Okay, so let's put this in a more kind of everyday context. Let's say that you have 2.93 grams of nickel ions melted from, gathered from melted NiCl2, which is nickel chloride, right? And I want to know how many moles of electrons are required to do that. So if we break that down, if we start with our nickel chloride, we know that when we put that in solution with water, if that's aqueous, in other words, it's going to dissociate to some extent into nickel cations with a +2 charge and a couple of chlorine anions, right? And again, all of this is still aqueous. Aqueous, aqueous, right? Now, we could look at what's going to happen to the chlorine as well, but the problem is just asking us about nickel, so let's stay focused on that. So we're just going to focus on the nickel and what's happening here. Well, the nickel, right, when it goes to the cathode, is going to hook up, we hope, with a couple of free electrons, right? It's going to hook up with a couple of free electrons, and it is going to create solid nickel. One thing that I want you guys to notice is that for every 1 mole of solid nickel that we produce, we use 2 moles of electrons because of the original +2 charge. Right? So that's going to be important when we go to answer this question. So before we can answer the number of moles that are required to reduce, this number of grams, we have to get this number in terms of moles, right? We always want all of our units to match. So there's a really easy way to do that, as you guys already know. You start with your 2.93 grams, and then you look up the molar mass of nickel. Well, I've already done that. I just looked at my periodic table real quick, and I found that 1 mole of nickel has been found experimentally to weigh 58.7 grams or thereabouts. And then I just did my calculation, and I found that that gave me 0.05 moles of nickel. Okay, easy peasy. Okay, so here comes the sort of next piece, right? They're asking us specifically about how many moles of electrons are required in order to do this reaction. Well, remember, this is not a 1-to-1 ratio. I need 2 moles of electrons for every 1 mole of nickel. So I essentially just have to, factor that in. For every 0.05 moles of nickel, I have a ratio of 1 mole of electrons, 2 moles of electrons for every 1 mole of nickel. And that gives me 0.1 moles of electrons needed. Ta-da! Okay, and so that's the basic sort of thought process. If in case you're ever asked a question like this, that all kind of comes back to, again, just sort of like common sense, being able to break down what happens in an electrolysis reaction, and then knowing that the rule here is 1 mole of electrons for every 1 Faraday of electrical charge. Those are the main takeaways that you need for SAT chemistry. Okay, thanks so much, guys. You are almost at an end here. In the next and final video, we're going to talk just a little bit about how regular batteries work in the real world.